Now, I want us to look at the relationship between electric field and electric potential gradient. Electric field and electric potential gradient. So in order to look at this, we need to agree that if we have an electric field there, and then suppose we have a positive charge that is placed within this electric field, it will experience a force, and the force it will experience, the electric force will be acting in that direction. So we can say this is the electric force it will experience. But if you apply an external force, against the direction of the field, you'll be doing work, and this will develop a change in potential difference, because you're moving from a lower potential to a higher potential. So meaning that this is going to develop a potential difference as you are moving it, maybe from this particular region, you are moving it in that direction a distance, let's say small x, delta r. So if you are pulling an electric charge against the electric field, you'll be doing work. And we are going to say electric potential difference that is going to be developed here is going to be equal to the work done per unit charge. So we can be able to say the potential difference is going to be the work done. Remember, the work done is force, and the force we're talking about is the external force. External force times the distance this particular charge has been moved, and that is going to be delta r divided by the amount of charge carried by this positive charge here, and that is going to be here. But something that you need to remember is that this force, because this is going to be pulled at a constant velocity, the charge is going to be pulled at a constant velocity. It means the resultant force is zero. So if the resultant force is zero, it will mean the external force applied and the electric force are equal. But the fact is they are equal but in opposite direction, and in that case we're going to say now change potential difference is going to be negative of the electric force. The external force is equal to the negative of this electric force times the change in R over Q. But what we need to also remember here is that electric force is equal to the electric field times the charge. So that means in this particular equation that we have at that point will be change in potential difference is going to be negative of QE change in R over Q. So you can see at this point this and this will cancel out, and then we're going to have change in potential difference is equals to negative of the electric field change in small r. Then this equation that we have here can be written as electric field, I'm making it the subject of the formula, is equals to negative of change in V over change in R. So that is now the relationship between the electric field and the potential gradient. So what does that really mean? If you plot a graph of potential difference against R, and R is the distance over which a charge is pulled in an electric field, then you are going to have a straight line graph. Then that means the gradient of this straight line graph is going to represent the electric field. So if you work out the gradient of this straight line graph, gradient will be equal to the negative of the negative of the gradient is going to be equal to the electric field. So anytime you are given a graph and then you are expected maybe to work the electric field from the gradient, like from a graph like this one, we are going to say electric field is equal to the negative of the gradient of that. So this is the relationship that exists between the electric field and the electric potential gradient. See you in the next tutorial.